Every year, we witness heartbreaking tragedies from buildings collapsing, walls giving way, and families counting losses from these tragedies. But what about if these tragedies could be prevented by just making informed decisions through professionals who actually know what needs to be done? So today we want to dive in a topic that is affecting millions of Kenya, but it's only talked about when something horrible happens. Joining us in studio today is a structural engineer that is going to help us understand constructional to separate constructional myths from what is actually needed to be done. I will be your host, Otieno, at Mwelekeo TV, the home of life-changing conversation. Karibu sana, Engineer Paul Kodo.
Thank you, Mercy.
We are very glad to have you in studio with us today.
Thank you. I'm glad to be here too.
Yes. So we want to talk about buildings and what actually happens, because we have seen from the news, it's one of those topics that when you hear, you just hold your heart. We hope that nothing has happened or lives have been lost. Yeah.
Sure.
So maybe just as an introduction, please tell our viewers who Paul is.
Okay. So my name is Paul Gordon Kodo. I'm an engineer by profession, civil engineer, and I specialize in structures. And we will expound much more on that as we go on. But as per now, just know we deal with buildings. We try and ensure that whatever Mercy has said does not happen, because we have that professional responsibility to ensure that people are safe and that our country is thriving by contributing to the built environment.
Beautiful.
Yeah. So I did my degree at the Technical University of Kenya, and after graduation, I've been in the field practicing, doing all we can to ensure that we are safe in our homes and that we don't waste resources. Yeah, sure.
Right. Now, how did Paul Kodo end up becoming a structural engineer?
Yeah, so I think it dates back to high school. I've been amazed by how people can come up with very elegant yet safe structures, the tall buildings.
Yeah.
When I first got into the profession, in my mind, I thought that we will be there doing the tall buildings and all these amazing bridges. But yes, that is part of what we do, and that is what drew me to engineering as a young person. But when I got to the profession, I realized that there is much more that actually hooked me into that a lot. So that is how I got into the profession. It was first about the amazing structures that were so appealing. I didn't even know how to differentiate between who is an architecture, what did they do, and who did what. But once I realized that there's a structural engineer behind what is standing there, I was drawn into it.
Yeah, beautiful. See, when we talk about engineering is so broad. So maybe if you would tell our viewers what specialization and which does what.
Yeah, so as you said, civil engineering is broad. Actually, it's one of the broadest engineering disciplines, because it deals with a lot of things. The term civil, if you can take it, you understand that it's dealing with much more than a personal thing. So you have a responsibility, a civil responsibility. So we have major branches of civil engineering, and one of them is structural engineering. Right. And in a simple term, structural engineering is dealing with high-rise building. High-rise buildings are those tall buildings that you see when you walk down or up a hill or somewhere. The skyscrapers that you hear from Burj Khalifa, and all these big buildings that you see. So there is a structural engineer behind that who is ensuring that those things are standing. They're also dealing with bridges. They can also work with water and hydraulics engineers in dams, the structures that you see there, the wall that is holding water, and all the way to the small perimeter wall that you have around your house. Yeah. There is a structural engineering perspective that is being used in ensuring that they stand. And then apart from that, we also have transport and traffic. So transport engineering is dealing with the pavements, the highways that we have, and designing the traffic to ensure that there is a good flow of traffic. We don't get accidents. Sometimes you've had the black spots. Some of the black spots that we hear, I know we have different myths, but most of the causes are because of design, that the way they were designed, because they're supposed to be designed with appropriate speed limits and how that pavement is designed. So apart from traffic, we also have geotechnical engineering. And for geotechnical engineering, we deal with soils. So we want to know how is this soil, can it support the structures that we are putting on them? And can it sustain the loads that we are having on them? And then after that, we have water and sanitation. So water, we deal with drainage, we deal with water treatment, how we can get dirty water from the river all the way to our dispensers.
Right.
So that is water engineering. Yeah, so those are some of the major engineering branches that we have. Yeah.
And so which one does Paul specialize in?
Yeah, so interestingly, when you are doing an undergraduate, you will go over all of them.
Okay.
Until you reach 50, and then you're like, no, I want to branch somewhere, because as you have heard, there is a lot in there. One person cannot specialize in all those things.
Yeah, that's true.
Yeah. So when I got out, when I reached 50 year, my desire to know how tall buildings are built drew me to structural engineering.
Okay.
Yeah. So that is what I've been doing, designing structures, buildings, bridges, and specifically, lately, of course, I've taken a much more specific interest in residential buildings and the small-scale structures that people do not know that they need engineering knowledge in doing them. So I tend to, in as much as I deal with those other major projects, I also tend to focus on these residential buildings and your mansionettes, your bungalows. Yeah. So that is where I am currently.
Okay. So maybe young students studying engineering would ask Paul, why specifically residence and construction consultancy?
Yeah, it is an interesting thing that I came to realize, that in as much as we have these developers who deal with mega structures like high-rise buildings that we have in Upper Hill, the UAP and all that, with them, they know and they understand that they need structural engineers.
Right.
But in the same way they need structural engineers to ensure that those buildings are safe, is the same way the people who are doing small projects like their houses, their mansionettes, also need engineers. But interestingly, some of them do not have access to these engineers because of perhaps their budget. And another factor is that some of them don't even know that they need these engineers. So when I noticed that, I got more interested, because I see professionalism as trying to help the society. So we just don't go in one direction where everyone is going. We try to look where has been ignored, in which area are we not taking much more interest.
Right.
And that is why I focused. Currently, I focus and I talk much more about the construction consultancy and the people who are doing residential buildings.
That is very beautiful. Maybe walk us through your typical week. What does Paul do in a normal day?
Yeah, we handle a lot. From designs, we design in offices where the structural work begins is on a laptop and a paper and softwares. So after that, we also have duties we are called on site. So I might be in Nairobi today doing the design, and then tomorrow I'm at Kisumu doing inspection of what I did at the background. So I need to go and check that are they doing what I designed. So yeah, we move a lot. From office to field work to meetings. It's quite a lot, but we manage.
Okay.
Yeah.
I want you to paint a picture for a young student watching Mwelekeo TV today, and he or she is pursuing engineering and specifically wants to do structural engineering, like engineer Paul Kodo, maybe walk them, paint that picture for them, how your typical workday looks like, your week, what you do at your leisure time, all that.
Yeah, so there is a first I've mentioned work. So someone will come and tell you that I need this to be done, or your boss, for example, if you are doing it on yourself, you may have work that you've taken from clients.
Yes.
So you wake up in the morning and then I look at them, plan my day, know how long am I going to spend sitting down doing designs, and then I can take some break. And so it's much more about trying to balance a lot of work that is in front of you, and you also ensure that your health is not affected because you cannot sit there for 12 hours. So a typical day will mean I do some work, then I take some break, I may take my meals, take a walk, and then come back and finish what I was doing. If there is a field work, I can work half a day and then take time to get to the field and do the inspection. So it's just balancing what you have and ensuring that your health as much as well as your productivity is not affected by schedule.
That's beautiful. So let us get into the gist of this discussion. We have seen from the news, we have witnessed story buildings collapsing and families have lost their loved ones, they have lost property and all that. From where you're sitting, what is actually going wrong? What is happening that we are experiencing these building collapses within Nairobi or just Kenya generally?
Actually, it's an interesting topic about houses collapsing. As you've pointed out, it is one of the tragedies that you wake up and read in the news and you're like, this should not be happening, especially when the society has given much more to ensure that people who are supposed to be responsible to this can actually prevent that, but you wake up and find them happening. So a lot is happening that is leading us to the final day of tragedy. When a house collapses, that collapse has not happened on that day. It began way back. Some of them begins way back from the offices. I told you that when I wake up, I can start doing the design. So some of the problems can be traced back to how that house was designed. And buildings are very unforgiving if you decide to be negligent. So the reason, if I go straight to your question, the reason why we are having this problem, number one, we have design problem. And then that is where people are supposed to do design. Either they don't have the capacity to do it. So a client hires someone who do not know what they are doing. And they, perhaps because of cost or something else, so they just do something without taking into consideration the technicality they're supposed to go into designing that house to ensure that it stays. So from design, there can be a problem. And then you may get a very good design from a qualified structural engineer, but during implementation, you find that clients try to avoid having them do the inspection or stand in when the implementation is done. Again, most of them to save cost or because they don't understand the importance of a structural engineer just being there, telling people who are working that I want this to be done this way. So there's a problem with inspection. The third thing is with materials. So materials that we use in structural engineering are they are designed to do a specific thing. When you do amendment without the knowledge of a structural engineer, for example, you've been told that go and buy this type of steel. And then you go to the store and you ask, what is the price of this one? You're told this is how much it costs. And then you ask, what about this other one? And then it costs something less. And then you come out there and say, steel is steel, just give me this one, you go and use them. So when you start doing that, compromising on the specified materials and the quality, you risk a lot. So those are the three main problems that we have. We have a problem at the design stage, we have a problem at inspection, and we have a problem at material that are being used. So when you compromise any of that, it has to come back to you in one way or the other.
You see, we've had a culture, especially in Kenya here.
Yeah.
I mean, from what we have seen, like if someone wants to build, anauliza, do I have an architect? Do I have a fundi? Come on, let's go. And they do not consult a structural engineer. So what do you think, what actually cost them? And I'm not talking about money when such kind of things occur.
Yeah. So just the way I told you, the structural engineer's work is not seen in a building. And I want people to know this. You cannot just walk in a building unless you have a structural engineering knowledge. You will not know that there was a structural engineer behind what you're seeing. What people see is the work of an architecture.
Right.
So when an architect brings you a design, you see a 3D, a very good 3D house. For that house to stand, you need a structural engineer. But the work that they're going to do is going to be covered in plasters and finishes and everything. So you will never see that.
Right.
So I think that is where the problem begins, because when you see someone and they have brought you a drawing and you're like, oh, this looks good. So what next? I need a fundi.
I need a constructor.
And then the fundi will go and do this and this and this without that knowledge that for that thing to stand, whatever you are seeing is just the end product. There's a back end. If you've done, if you, for people who are a bit familiar with software engineering, you heard that there is a back end and then there is a front end.
Yeah.
Front end is when you log in and then you see beautiful pictures and all this. But behind that, there are very complex codes that were created to ensure that whatever you are seeing
holds together.
Yeah. So with that, then you realize that for you to achieve what your architecture wanted you to have, you need a structural engineer. Whether you know that what they are doing or not, you just take it that you need a structural engineer. Otherwise, you will run into the problem that some of them we've mentioned of houses collapsing. Because before those houses collapse, no one knows, because they walk into the house, everything is okay.
Yeah.
But all of a sudden, everything is crumbling down. It is because the work of structural engineer was ignored. Yeah.
Okay. And as you have mentioned that sometimes these problems don't just happen on the day of the tragedy. Now, you have done inspections maybe across Kenya, right? So maybe what are some of the issues that you find are happening and they actually look fine from the outside? Outside looking in, they look okay, but you as a structural engineer, you can spot that there is an issue here.
Yeah, so that is interesting. Most of the time we are called when there is a problem. So someone has seen a very huge crack on the wall. They tried plastering it, then after a few months, another crack.
Again, yeah.
So they call you. So when I get to this project, I've seen quite a number of problems that could have been avoided, but because people who did it did not know, they're there. For example, we have undersized structural members. A structural member, for example, can be a slab. We have columns, and we have there are some walls that we carry the load. So when they are undersized or they used fewer reinforcement, the steel that we buy, the chuma, the kawaii that we buy, when they use small amount, a problem arises, or they use a smaller slab because they wanted to save on cement or concrete or something. So those are some of the problems I've seen. And another problem that I see, which interestingly the problem do not appear immediately, is on foundations. So I go to a building, someone is seeing a crack on a wall, but actually the problem was in the foundation. Kenya, we have different types of soils. And the reason why we really insist that you should have an engineer all through your project is that from understanding the soil that you are going to build that house in. So people go to a black cotton soil, they just lay the normal foundation and then lay the slab on top of a black cotton soil. And few months or few years later, there are cracks everywhere. The tiles are coming up. So those are some of the problems I've seen. Undersizing structural members, using fewer or smaller reinforcements or the steel, and building on having a bad foundation, especially, for example, building on a black cotton without proper design of the foundation. Yeah.
Okay.
Yeah.
That is very insightful. So there's this common statement we've had that if a building is still standing after 5 years, no issue, it is fine. There's nothing wrong with it. From your perspective as a structural engineer, do you believe that statement to be true?
Yeah, that statement is not true, and it costs people who believe it much more than they expect.
Oh, really?
Yeah, because I want to tell you something.
Mm-hmm.
When we design a building, for example, there is what we call design life or lifespan of that building. So you know that building a house is not easy. It takes a lot of money. Anyone who has built a house knows, especially when you are doing a good bungalow or a mansionette, you will part with hundreds and hundreds of thousands or millions and millions of money. So us as professionals, our work is to ensure that your investment stands for a good time to ensure that it is worth it.
Right.
So when we design most of these buildings, you see the buildings that we use concrete and steel, the design life is between 70 years to 100 years. What that means is that within that time, you should not have any major problems. You should not have to replace your slab. Your slab is leaking so bad, or your foundation is giving way. So it should take 70 to 100 years. The problem that people have is that you can build a house, then 5 years you think it's just okay. But 10 years, things start falling apart. When that happens, you might not click that perhaps the problem is the person who did the design, because number one, you don't know that when that person did for you the design, that house should stand for 70 to 100 years without any problem. So a house may be standing, but it is just a problem in waiting. You can imagine if you are making an investment that is supposed to help you for 70 years, and then it only helps you for 10 years. Right. You see, you've run a lot of losses.
Yes, yes.
Yeah. So those are the things that we know, and we try to explain to clients that nyumba si nyumba vile wanasema, nyumba ni nyumba, bora haijaanguka. No, that is not what really happens. Yeah. So the house should be designed well and to accomplish its lifespan, which is a standard. We all know that a good designed building should take that long. And if you just think about it, what is our lifespan? The average lifespan, or it's about 70 years.
70 years, yeah.
So that means you should build once, and then the person who should come and do the repair, a major repair, is your
child,
next generation.
Right.
Yeah. So if you keep on doing repairs, something went wrong. Yeah.
Okay.
Sure.
Now, as you have mentioned, that sometimes one of the things that clients keep asking is the cost. Now, some of them have said that hiring a structural engineer is actually very costly. So how would you respond to that?
Yeah, so it needs much more reflection to understand that it is way cheaper to hire a structural engineer. And I want to paint this picture so that our viewers can try and understand why we are saying this. You are putting up a very serious investment. The way we've said, you will start with millions of money to build a house, or 900,000 or something. That is a lot of money. A structural engineer, for example, for these small buildings, if I take the small buildings that I work with, may charge you, for example, 50 to 100,000 to do for you a structural design. That structural design is what is going to direct people who are doing the buildings to ensure that that building stands. Inspection fee, for example, site visits, they're 10,000, which is just fuel's money. So it's a 10,000 for fuel. Someone might come for you for inspection 3 or 4 times, and then your house is done, for example. I want you to take that cost and then put it against 1.2 million, 2 million, 4 million that we are going to use, and then also add the time factor. So you've worked with someone who has charged you 20,000. You've risked an investment worth 10 million for that. Instead of these 10 million serving you for 70 years, after 10 years, you're going to build another one.
Right.
So if you look at it from that perspective,
in the long run,
you realize that it is much, much cheaper. And some do not even go that long. They don't even take 10 years. I remember there's a house that I think I dealt with just this year. The owner has not stepped into the house, but already we are doing repairs. And you won't imagine that the repair itself is 700,000. So they have not stepped into the house. The people who did the work did a bad job. And now we have to come in when it is late to do that repair. So if you look at the investment that you are making, you will not want to risk it for this small fraction of the investment you're making. Number one, you've bought material. Material is very expensive. It takes 60 or 70% of project cost goes into material. And then, even if you were to hire an engineering firm, they will only take 4%. If it is a big project, they will only take 4%. So how will you risk 96% to save partly on 4%? It is not worth it. So if you look at it from that perspective, you will realize that the way you do not want to compromise on concrete or on steel, you will not want to compromise on the person who is going to ensure that whatever you've bought has served you well over the time. Yeah.
All right.
Sure.
Now, what usually happens when a client comes to you for a residential project?
Yeah. So when a client comes, we first discuss what they want. And one of the things I try to do recently, because I know we are in the economy is bad.
Yeah.
So we try as much as possible. If you get a good engineer, they will try as much as possible to ensure that you get a good, safe building at the minimum cost possible. And I'm saying possible because I'm not going to compromise on your safety.
Right.
So I will do a lot of work trying to design with the knowledge that I have and the principles, trying to design that building to ensure that we use just the right amount of material to get to the safety and longevity of that structure. So when a client comes, first they will, if they have gone to an architect or they have someone who has drawn for them the house, they will bring the house and then we'll do the assessment. And then I will sit down, do the structural design and try to optimize as much as possible so that we just don't use too much material. And also the aspect of time. So I do the design. After design, we can make an agreement. One thing with engineering is that people do this. You can come, I do for you structural drawings, and then you get another engineer, as long as they are qualified to do the inspection and all that, it is allowed. But I usually try to talk to clients that let the person who designed go with you all through, because they understood what they were doing.
Yes,
it is allowed because as long as they are registered and they have the license, you can just have someone, but it's better to do this. So after designing, I will talk to clients. If they want me to continue with them to the implementation phase, do the inspections, I will do that. Yeah. So it is about looking at their project, producing for them the drawings, and then explaining to them and trying to agree if we can continue from there or not. Yeah.
Okay. Yeah. We saw that recently you did a very interesting piece. Yeah. Could you kindly enlighten us more on that?
Yeah, the last piece that I did, second last if I say that, is about a water project that I visited at Vihiga. And the reason why it was so important for me, it's not just a project. I tried to understand what the person who designed that structure was having in mind.
Right.
And it was about sustainability and optimization, which I think I'm much more drawn into. We have finite resources. The way the economy is hard, our environment is crying, it needs to be protected and all that. So a good engineering, the project that I had, the reason why it was interesting for me, is that the designer tried as much as possible to use the least material to achieve the desired project that was brought to them. And this included trying as much as possible to use least energy in running the project, and also ensuring that the ultimate product is not compromised. So that is what I'm trying to do with your houses and everything that I put my hands in professionally. I mean, great engineering is not using so complex machines and most expensive machines. A great engineering is trying to achieve result with the simplest method possible,
right,
and the most cost effective, because that is what we have to save our environment, also to save your pockets from.
Right.
Yeah. So that is what I did in that article. I was trying to highlight, and for the upcoming engineers, you can go and read that. It is a good principle that you don't complicate things so much, but try, as long as you have the principles. The most important thing as a professional is that you understand the principle. From there, you can create solutions that people didn't even realize could exist. And if you have the goal, because we work with constraints, we work with constraints of finance, constraints of available resources, and even time. So when you have these constraints and you have the principle, you can balance them and get the result with the best use of resources, time, and quality. Yeah. So I still stand that great engineering should be about simplicity and understanding how nature works and getting the best result. Yeah. That is what I saw in that project.
Okay. So how can our viewers get to read that piece?
Yeah. So the article is my LinkedIn. Yeah. So at Paul Kodo. So yeah, you can find it there.
Yeah. Okay. Now let us dive deep a bit. We have experienced recently in Nairobi, we experienced very heavy floods, and every time we experience such things, such as perimeter walls, we find they have collapsed. And now, from your perspective, what do you think people are getting wrong while building perimeter walls?
Yeah, so perimeter walls are interesting because people think they're so simple. It's just a wall built. It's a long wall that is supposed to protect you. Yeah. So people think they don't need someone who understands how things work to build them. So just get a fundi, they dig a channel and then start laying the foundation.
Yeah.
The problem is there is no smaller project as long as it requires structural engineers understanding. You need to have one to help you. So the problem that we have with perimeter wall is actually on the soil and the foundation. It's a small wall, but if you don't do proper foundation, it is not going to serve you. It might serve you for some times, but it will either collapse or it will, it will not just serve you throughout the timeline that you're supposed to have it. So if I just paint a small picture,
yes,
you can be in a black cotton soil, or your land is in a black cotton soil, and you just build a wall. There are a lot that is going on. There is the property of this soil. And one of the nightmares that engineers have is dealing with black cotton soil. Right. It's not a nightmare if you understand what you are doing, but it's a nightmare because if you mess, it will come back to you almost immediately. It's very unforgiving. So you build your wall on a black cotton. When it rains, the black cotton takes in water, swells, that stretches your wall. You start seeing cracks.
Right.
When the rain stops, the water drains slowly and then it shrinks. So you can imagine your wall being stretched and compressed, stretched and compressed. The next thing is cracks.
Right.
And if it is too much rain and there is a building there's a water surcharge, the water puts pressure on the other side of the wall, it can come down. And again, you know that when there is water and mixed with soil, it becomes strength. The strength becomes weaker, so it can give in and then the wall falls. So even if you are doing a perimeter wall, and they are not cheap, by the way. People think perimeter. Whoever has done a perimeter wall for a 50 by 100, they know how much they've spent.
Right.
Yeah, it's not cheap. You spend 700 to 1 million depending on how you are doing it, including the gate. So you can't just throw a 700,000 project like that. You need someone to help you. Yeah.
Now, someone kule nyumbani is asking this question. I just want a simple perimeter wall. Why would I need a structural engineer for this? How would you respond to that?
Yeah, it's the same thing you're saying, that it is not just the way you're saying, just a perimeter wall.
Yeah.
Number one, you're going to spend money. You know the cost of cement. How many cement are you going to use? How many ndarugos, the matofaris, we're going to use the stones. Yeah, if you look at that cost of that project, it is too much. And the way I've told you, the way I've just mentioned before, a few minutes ago, even those perimeter walls needs proper designing. So if I do proper designing and foundation and steel work, it will serve you for long. So as long as you're going to spend money in a project and you know that it needs someone to do it, first ask the structural engineer and let them tell you, you don't need me.
Okay.
Yeah. So before that, don't just throw the investment. Yeah.
Okay. You have mentioned before something like soil testing. Yeah. Explain it to our viewers why it is important not to skip that bit in construction.
Yeah, there is a misconception, and I see this with many engineers, especially us young engineers. We do good design of houses, but when it comes to foundation, yes, we design the foundation. Whenever we are designing a foundation, one of the things that we need to take into account is the type of soil.
Right.
A person who is building on a black cotton is different from a person who is building on a maram, the more stable soil. They may have different foundational designs to meet the type of soil they're having. So that is why it is important to do soil testing. With soil testing, we know the strength of that soil. We know how much that soil can carry when we are designing the house, or how can we adjust the foundation to ensure that that soil bears the load that we are putting on it, which is the whole house. So another misconception is that I can just see this is black, then it is black cotton, or I can just see this is red, it is a good soil.
Yes.
That is not true. You'll be surprised. Sometimes when we take these samples to the lab, you're like, oh, that was a very strong, it sounded like a maram. Not knowing that the maram is just some few millimeters.
Yeah.
So you just saw, but deep down, you have a whole different thing.
Right.
And I want, if you watch some documentaries about big projects, even in other countries, there are situations where a whole village has sunk because people did not take into account the type of soil they were building in. So they just build because they are seeing a good maram or rocky place, but underneath it is a whole different type of soil. So the reason why we do testing is to ensure that we know what we are working with, not just by assumption or just by observation. Yeah. Because it can be deceiving to just see and say, this is okay. Yeah.
Beautiful. Now, for those joining us, maybe in the midst of this interview, we have Engineer Paul Kodo, who is helping us understand why we need informed structural decisions while doing construction. So we have seen this common trend, the precast technology, precast concrete technology. And Kenyans like to go with the trends. So what are some of the things that you would want them to understand before going with that route of construction?
Yeah, precast is actually a good. It is an interesting technology because it has its advantages, and if you are in any profession and you hear there is a technology, there is a reason behind it. There is a problem it's trying to solve that its predecessors were not solving.
Right.
So if you hear precast, there is a specific problem that is trying to solve. And and if I mention some, the speed at which you can complete a project.
Right.
You know that when you are doing the in situ casting is when you do the concrete on site and you bring the cement, you bring all these aggregates and then mix them on site and then cast. That is called in situ casting. That takes time because there are principles. This freshly cast concrete has to take some time to cure before you proceed.
Right.
And that is one of the reasons why one of the buildings came crumbling down. A very tall building is because they were trying to hasten the process. They did not want to follow the process of curing and all that. So for a good project, you have to do that. You have to follow the curing process. Precast helps you skip that.
Right.
Because these slabs, these columns, these beams have been casted in the factory.
Right.
So you just bring them and then you
just begin working on your project.
Begin working on combining them. Yeah. So it saves on time. That is one benefit. And you can see there is a big project that is going on along Kenyatta. Is it Kenyatta Avenue? The one going to Talanta.
Right.
If you look at those big projects, you will realize that they don't cast everything on site. They bring those big piers and big decks already casted. That is called precast, and then they just combine them to form the structure that they wanted. So it saves on time. Number two, precast can help you get the precision that you might not get when you are on site. Because when you're on site, you create the formwork manually with people, and then do all these things. So there might be some millimeters of misalignment somewhere. But with precast, they are already well-refined way of doing them from the factory.
Right.
So you will get a more accurate measurement and all that.
Right.
So those are some of the benefits of precast, the speed and then the precision. Now, the problem is that people think that now because it has already been made, I can just bring it and then niunganishe and then I go.
Yeah.
There is a big problem with that. There is a wall that was last month. I was at Joska doing some inspection. Then on my way back, I saw a wall that has collapsed, and it is a precast wall. And you can immediately see that the person who was doing this just thought they could just take those things and then screw them together and all is well. They did not design the foundation. They did not do the engineering perspective of understanding that how can I do this? Even what panels should I bring from the factory?
Right.
Because when you go to the factory, it's like you're going to buy something. You need to know what you're buying.
Yes.
So if you don't have someone who understands that, then you will end up just buying something because you had someone did it somewhere, but the type of soil they used is different. The size of the panel could be different, and all those should be designed. So even if you are doing precast, even for a wall, get someone who understands. Get us an advice from a structural engineer to tell you that this is what we are going to do, and this is how we are going to design this. And if you do that, you will realize that you will reap the benefits without risking losing everything because you are trying to use a technology that you don't understand. Another thing is that you've realized that there are many companies that are coming up, firms, doing that, creating those precast members.
Yes.
There is an issue of quality. You need to understand that whatever you're buying is what is written there.
Right.
Sometimes if I go there, I may ask them, I want you to test one of the members so that I know that it reaches the capacity that is written there. Because if I just buy it and you told me that it is 20 MPa and then I go there and you did something else, and my design, I designed with the strength that is written. So if it collapses, who is the responsible? It is me. So I have to go there and ensure that whatever they are giving me, because all those members also have different strength designed for different types of works. So you have to have someone who knows to help you go through that process here.
Right.
So it is a great technology, but don't think that you can just do it without the knowledge of that we previously have. It's easier for a structural engineer who understands to help you get the best out of that technology. Yeah.
Okay.
Yeah.
So maybe to our viewer who was actually considering doing a precast for their project, what is maybe from the top of it, maybe 3 things that they should not miss while selecting that?
Yeah. So one, first, the way I said, ensure that there is a design. There is a design that you have so that you're just bringing material to fit in that.
Right.
So don't just say, I need this size of house, so walls nihi, columns are these. So first, ensure that there is a design. Second, ensure that there is whatever you're buying is what you need from the design. Ensure that the strength of those members are what you need from the design. And then have professionals to do what? Installation on site. There is an interesting project that I saw that we dealt with a few months ago. They used blocks and beams. Blocks and beams are the ones you see, the precast, the hollow ones, hollow parts. You just lay the beams and then you arrange the blocks. You won't imagine that the only mistake that those people did is that they oriented the blocks in the wrong direction, and that building we had to redo. And it was done, and it has to take hundreds and hundreds of thousands to redo. So in as much as precast works, number one, ensure that the people who are doing installation understand, ensure that there is inspection, ensure that the product you are getting from the companies actually has the strength that is written there, which should match what was designed. So the process is still the same. Get to a structural engineer, let them design for you the product, then outsource the right material, have the right people to implement it on site, and let this structural engineer do the supervision. Yeah.
Very insightful. So we're almost coming to the end of this interview, but we would want to understand from Engineer Paul, over the next 10 years, how do you see this structural engineering in Kenya progressing or developing?
Yeah, I have this hope that in the next few decades, we will not have this unfortunate news of houses collapsing.
Yeah.
That is number one. Number two, I also believe that with the right effort that we are trying to make, especially the young engineers, to try to educate the public on the importance of having this, to try to make them understand that these professionals are not just there to take your money, they're actually there to protect your investment and for your safety. And they have professional responsibility and ethical responsibility to do that. So I hope that in the next few decades, people will not be unnecessarily spending money that is not helping them. For example, having large oversized columns, having houses members that you don't even need, or using too much material that you don't even need. So with that, you will realize that it also gets back to the environment. I hope that by doing that in the next few decades, our construction industry, especially in Kenya, will be able to work in a more efficient way. Besides helping the clients, they should also help the environment by ensuring that we just use the right amount of material that is not harming the environment. So, yeah, if you ask me how I see, that is my hope.
That is your hope.
And what I'm doing, what I'm doing I'm doing at the personal level to try and achieve that is through sensitization, what we are doing here. And I thank you for this. When we speak with clients, people often think that clients are just adamant, they want to save money. But I realize that ignorance is a very big factor that is affecting their decisions. Once I've had a client and we have talked, the way we've talked with you now,
right?
I think the next time you're going to build, you are not like, no, let me just get a fundi. You will be having all this understanding, and most of them actually ends up doing the right thing next. So my dream is that we as engineers, we have a responsibility to inform the public. We don't expect the public to know all these things if we don't take the initiative. For example, the one you've taken here, we have taken here to have this discussion. So we have to explain to clients. We should not just let them say, oh, they want to save money, let them just do that, and then they told you moment. That is not what we are supposed to be doing. We are supposed to be continuously informing them and trying as much as possible to work with other professionals in the built environment, for example, the architectures, to ensure that we are achieving our responsibility of sustainable construction and also ensuring safety of the public is put as the number one thing. Yeah.
Okay.
So my hope is that in the next 10 years, we shall be some good percentage into achieving sustainability and wise use of resources and safety. Yeah.
Okay.
Sure.
Okay. So, Engineer Paul, there's our viewer there watching us tonight and is asking, just wants to understand they're about to break ground on their project and they want to take 2 or 3 most important things from this interview. What would that be?
One, the most important one, build right from the beginning. That is the most important thing I will tell you. The cost of repair is so expensive, unnecessarily expensive if you can do the right thing from the beginning. So if you're planning on building a house, the procedure is this. First, you get someone to translate your idea into a drawing, into paper, for example. And that will be someone who understands architectural design. So you want a 4-bedroom and you have this number of people in the house, and you like modern or the old, or you like the open kitchen and all that. So you get an architectural engineer to translate that. No, you get an architect to translate that to a paper. Take that paper to a structural engineer.
Right.
And let them look at it, create for you another drawing which you need, called structural drawing.
Mm-hmm.
And then after having that, talk to them. If they can help you do the supervision and implementation of what they have drawn, talk to them to do that. Then ensure that they inspect the project that you are doing. You might part with some few coins which you pay those professionals,
Mm-hmm.
but trust me, in the long run, you will be the happiest person and the safest person. Yeah.
Right. Just share with them how they can find you.
Yeah. So you can find me through a call,
Mm-hmm.
which
You can share your LinkedIn profile,
Yeah, so-
Facebook, and all that.
So Facebook, it is Gordon Kodo. My LinkedIn is Paul Kodo. And yeah, so mostly I converse with people in LinkedIn and Facebook. And you can also call me. I can mention my phone number.
And that's okay.
Yeah, so it is 0700-691-474. If you give me a call and then you explain to me what you want, I've worked enough in this industry. Even if you've not met an architecture, I know we have friends who do those things. So we can walk you through all that process to ensure that your project is a success and you've just used enough of what you needed to use to get what you wanted. Yeah.
Beautiful. There you've heard it. We have heard from the engineer that successful construction is not just about bricks, stones, and cement. It is about making informed decisions that ensure that your building stays up to the lifespan that is expected. Thank you so much, Engineer Paul, for sharing your insight with us.
Okay.
If you find this episode informative, don't just like, please comment, share, and subscribe to all our channels at Mwelekeo TV. I've been your host, Mercy Otieno. Till next time.